Purpose of this video is to be able to find equations of tangents given the equation. So we're trying to find the equation of the tangent to the curve y equals x squared at the point where x equals 1.5. I'm going to use the graph to demonstrate what's going on here, but you don't need the graph at all to solve these problems. Here's x equals 1.5, and here's a point on the curve. Okay, so I'm trying to find the equation of the tangent. I can draw roughly where this tangent is. Okay, you'll be able to do a better drawing than me. I'm trying to find the equation of that line. You'll remember the equation of a straight line is y equals mx plus c. And to be able to find the m and the c values, I need, at a minimum, the gradient, okay, m, and a point. So I'll see what I can do. Can I find what the gradient at this point is? Yep, definitely can. That's my derivative. So I know that dy dx, if my function is x squared, my slope is going to be 2x. I'm interested in finding the slope at x equals 2, x equals 1.5. Okay, so I'm looking for the slope when x equals 1.5, so I'll substitute 1.5 in here. Okay, the slope is 3. Okay, and that'll be my gradient of that tangent line. So I've ticked off this gradient already. So I know the gradient. All I need to know now is the point. Okay, I know that this point is going to be 1.5. To find the y coordinate, I just need to square that value. Okay, so I need to find the y coordinate of the point where x equals 1.5. Okay, so into y equals x squared, I'm going to sub x equals 1.5 into there. So y equals 1.5 squared, y will be 2.25. Okay, so my point is 1.5, 2.25. And now I can tick off that I have the point. So now I should be able to find the equation of that tangent line. Okay, so I know m equals 3 and 1.5, 2.25 is a point. I'm going to sub that into y equals mx plus c. So this is my x value, this is my y value. 2.25 equals 3 times 1.5 plus c. Okay, and then I can just rearrange this to find my c value. Okay, I've now got my c value. So I know that m is 3 and c is minus 2.25. The equation of the tangent it will be y equals 3, okay, because my m value is 3, x minus 2.25. Okay, so this is mx plus c. Hey, can I check this on my calculator when I'm in an exam? Yeah, absolutely. All I need to do is go into my graph mode and graph my function, x squared. Make sure that I can see where 1.5 is. Yeah. So when I graph the thing, I need to go into menu, make sure that derivative is on. Okay, and then I'm trying to sketch the tangent. So if I click sketch, I want the tangent, F2, and I want it at 1.5. 1.5, press enter. It'll give me the point. I think if I press enter again, it'll give me the equation. Okay, y equals 3x minus 2.25, and that's the same as our answer. Okay, so remember we can always check on the graphics calculator. So at the bottom of the page here is a problem that you can practice along the similar lines. Okay, some of the textbook problems aren't so good. We also need to be able to find the equations of normals. So if here's same scenario, same equation. Okay, this was the equation of the tangent. Okay, the equation of the normal is the one that's at right angles to this. Okay, so there's a right angle there. This is the normal. Okay, we're trying to find the equation of that line. Again, probably forget this from year 10, but this is our relationship between the equation, the gradient of the normal and the gradient of the tangent. Some people like to remember this as the gradient of the normal times the gradient of the tangent equals -1. Okay, either way, and you'll be able to solve both of these. Okay, so to find the gradient of the normal, I first need to know the gradient of the tangent. Okay, I've done this already on the previous page, but I'll do it again just for fun. So I'm first finding the gradient of the tangent. So I need to know what the derivative is. Okay, the slope at any point. Okay, and I'm interested at this x equals 1.5 point again. So I'm going to sub in x equals 1.5. So the derivative when x equals 1.5, 2 times 1.5, okay, we know that's 3, and that's the gradient of the tangent line. I'm trying to find the gradient of the normal. I know that the gradient of the normal is -1 on the gradient of the tangent, so I know this will be -1 on 3, okay, because my gradient of the tangent is 3. Okay, from here, again, I need to find the equation of any line. I need the gradient and a point. So I know what this gradient is. I'm not going to find this point again. Okay, we know that it's 1.5, 2.25. I'm just going to go ahead and find the equation of the normal. Okay, so I'm going to sub in m of -1 on 3. And the point 1.5, 2.25 as my xy into y equals mx plus c, okay, to find the equation. So I'll go ahead and do this. Okay, remember we've got y equals mx plus c, my y value is 2.25, my m is -1/3, okay, times 1.5 plus c. So my c value will be 2.25. It'll get a little bit messy here. Okay, probably better suited to calculators. Okay, c value of 2.75. Okay, so my equation of the normal, okay, in y equals mx plus c form will be y equals -1/3 x plus 2.75. Okay, let's have a look at this equation. Yeah, I've drawn it pretty sketchy. It probably should, the normal probably should have, well, we know that it should have gone through 2.75, so it should have looked something like that with the right angles. And make sure we can still print it, yeah. Okay, again, I should be able to check this on my calculator. Hopefully I've still got it graphed. Okay, so I'll draw you again. I want to sketch the normal at 1.5. I'll press execute again, and there's my normal, y equals -0.333, so -1/3 plus 2.75, and it's drawn it in for me at right angles, so all this stuff works. Here are a few more questions for you to practice. That combined with the one on the previous page should be more than enough for you to master this concept.